it's not a priority, but it's something that I've got vaguely running, and if we have the opportunity, we'll optimize enough to make it playable. Not that we expect that to be a great gameplay experience, but partially because we've refocused on on being more targeted at the actual game we're delivering rather than our pure visual lushness on things. It would be nice if the game started up and ran on on an arbitrary system, even if they don't have a hardware card or properly configured drivers or things like that. So the Windows version may wind up having a couple extra DLLs for that, but we don't have separate refs anymore because even if we do have a software GL, it's still all the high-level stuff is exactly the same. So there's no equivalent ref soft ref GL. And if we move the client-side game and the server-side game stuff into interpreted data files that are portable, just down to 1x, which is a really positive thing. And so again, there's a slight cost of the issues that you use in power and flexibility with the interpreter are, there's definitely a speed cost. It's probably a tenth the speed of raw C, which will have an impact on like number of players you can run on a given dedicated server, but not as bad as you think, because if you profile like the current stuff, the vast majority of the time is actually spent in the main Quake2.exe where it's doing the world physics tests, sweeping boxes and testing points. That's the bulk of the time. I mean, there is a noticeable chunk of time that's just spent looping around things in the server game, and that part will effectively get 10 times slower if it's all interpreted. But we've made certain optimizations in how much of the complex server-side testing we actually do. So we've gained some speed there, but we are going to give some speed back here. And with the interpreter, it is likely that the total count of players served per megahertz will go down. But we've got faster systems coming out, and it should all kind of balance out. I think that the benefits we get from the extra flexibility of running on arbitrary platforms and the lack of an extra DLL kind of outweigh that. One of the other things is, since you don't have, when you compile stuff with the interpreted C here, you actually have to, there is no standard C library, so any kind of functions that you actually use, you have to replicate. We've got like a little file of string compares and mem copies and stuff like that are actually just implemented in code. It's actually an instructive thing for a programmer to do sometime, to try linking the build libraries and to see how much external stuff you actually are relying on. So I mean, we'll provide some, the stuff that we actually need, we provide in the library there. And certain things like mathematical intrinsics, the sines and cosines, will be provided by the main system. And there's actually the amusing little aspect of, there may be some cases where you may actually, if performance does become a problem in the interpreted language, you can actually write virtual assembly code targeted towards this processor, because the compiler just emits assembly code, which is run through the assembler, and if you need something to be much faster, the compiler is not very optimized. You can go in and generate your own assembly code for certain things that may be tight loops, and we'll probably be doing that for some, because if something's really important, we'll make it a built-in system function, retracting system, and then it happens in regular C. But there's this whole class of functions where performance is kind of important, but not so much that one plug in the API to the system implications. It does complicate things a little bit more than like the Quake2 interface with things, because you can't share pointers between the interpreted and the compiled part of the code. When I bring it up initially, I'm in a shared address space, but otherwise that's not secure, because you can always, given access to somebody's address space, the architecture, you can always wind up writing over their stack to something and achieving whatever you need by generating program code in their space. But so the intention is that by the time I'm done, I have to have all my internal APIs restructured so that nothing returns a pointer from system space. The system can look in on the interpreted space, but everything's going to have to be like marshaled in separate areas, and that's going to be a little bit tedious in some areas. It requires a bunch of changes in our current API. But the system trap is basically like when the interpreter tries to execute a null function pointer, it's a trap in the system. It can examine what it wants to do there and perform whatever it needs. So there are going to be certain operating system functions that just aren't available. You're not going to be able to touch the registry on Windows or anything like that. There's not going to be file access functions. Now that's one thing which is one of the tighter decisions. There's reasons why mods, especially server mods, would want to access file systems or open additional sockets and things like that. But it comes back to the security issue of, if you let people run to, the legs entity, the torso entity, the weapon tagged onto that, a muzzle flash on there, possibly stretch power-up effects on top of everything else, looping sounds. All that can be done on the client side with very efficient network utilization. Since we're basically sending over small cues, like all of the animation is not strictly done with a frame. The server doesn't send over like frames of information like it did in Quake. For one thing, when you've got multi-part models, that doesn't make as much sense. We could have extended it to a frame for a small set of models. But basically it sends over animation cues, which means that even if you're dropping packets or you have a variable receipt rate from your internet provider, you still get smooth animation of everything. And that carries over into a whole lot of different aspects of it, like the parametric projection of missile maneuver times, and a lot of that is in the client. Now, a lot of that's code that nobody's going to want to touch, but it is available there to, you have access to that at the level to go ahead and copy and duplicate other types of objects. Like if somebody wanted to do an airplane modification, you could go ahead and write your own client-side prediction code for an airplane. So you could have you'd have two options there. Either you could go ahead and mark it as non-predicting on the client side, where you would have whatever control you wanted on the server side and just lag. Or you could go ahead and implement the same thing that takes in a user command in the current player state, modifies it based on whatever control you want. So basically the entire thing that was hidden in Quake 2 is now visible in the server and client. So you can implement any kind of user modification you want. It really is very close to the kind of universal game engine in that the core part of the engine handles a lot of the messy details of the networking, establishing connections, communicating information in state, and then managing capacity with snapshots over the client. But you can interpret those just about any way you want. They're kind of just blocks of data. There are some assigned aspects to things where there's a little bit of structure where it's like fields of the entity can be model 1, model 2, entity 1, entity 2. But they're kind of general purpose because they don't actually do anything necessarily on the client side. It's up to a matter of what the client looks at the entity type field and decides how to interpret the fields there. So you have full freedom to create completely new types of entities that are going to be presented in different ways. And you also have full control over all the 2D aspects of the screen, all the status bar stuff, the crosshair. You've basically got a layer on the screen where the rest of the game system can layer consoles and menus on top of that if you want, but you can do whatever you want on there. You have access to all the rendering primitives that are available from the ref. You can draw the pictures, set up anything for the entities, and pretty much completely full control. At the end here, question and answer times, I would like to go over anybody that has their ideas for major projects that they'd like to be undertaking and make sure that there is all the functionality that you'd like to be able to do there. Because I think that everyone's going to be really pleasantly surprised with what you're going to be able to do here. Although, again, it comes back to the more freedom you have, the more work you can expend to try and accomplish what you want. And that's always kind of the trade-off we've been tracking since, since Wolfenstein or Doom. The more freedom we give you, you can spend more and more time trying to get something, but you have the capability. That's what we're trying to do, is just make sure that the architecture allows you to do whatever you want to set yourself to as far as how much work you want to put into something. We want to make sure that there's not giant architectural stumbling blocks where you get to the point where you just can't do something. Like in Quake 2, you just really can't change the size of models because a lot of that information is hard-coded into the PMove stuff. That's an architectural limitation that that really should have been removed. Like some of the other limitations with the amount of state that can be communicated from the client to the server, like config strings now can be arbitrary length, so we don't have. There's like the really awful hack in Quake 2 of the layout string extended over multiple config strings of fixed size, and I should be ashamed of myself for doing that. Now they're just they're arbitrarily allocated, and you can pass any information you want over, which is a lot more relevant now that the client can actually be this autonomous entity where you pass over whatever information you want. So there's like two types of game information which are communicated, and the connection process has also been cleaned up a whole lot, where Quake 2's connection process was, all through Quake, it was really kind of a mess because you would have these different elements of connection, and there were array states, and you could sometimes get kind of wedged in different parts of connecting because there were the whole problems of trying to communicate a large block of data at the start over our UDP connection, where in Quake 1, where we said we allowed 8K packets, it was not that big of a deal, we just fit inside there. But when we started running into like all the problems where some routers don't pass large packets and we had to go down to the 1.5K packets, there were a number of problems there where you get reliable overruns a whole lot more frequently, and there were limits on how much you could pass. The server had to go through this fairly complicated procedure to kind of shuffle over a bunch of data. You know, it would shuffle over parts of the config strings, parts of the entity baselines, and it would run through all of these lists over multiple messages while the client was also sending messages, and it was a pretty messy situation. There were some problems internally with it. What we really wanted was the option of an atomic connection process, where when you connect, you get this block of data atomically without the chance of interfering in between, and then you get snapshot updates after that. And there's only two types of messages now. There's the initial game state that you receive, and then there's the snapshots that you receive as gameplay goes on once you're active. Now, to do that, we wound up, you still have to have the same complexity where someplace something has to be fragmenting these large messages into packets and dealing with retransmission and all that. In Quake 2, that work was handled by the high-level server code, which interacted with all these other aspects of the game, the way the player's sending messages, all that stuff. What I've done now is move that part down to the lowest level part, where you can actually now send a packet that's up to 16 or 32K in length, and then the low level code handles the sequencing of that, which to the high level makes it atomic. I mean, at the low level, it's still a matter of passing multiple packets and waiting for acknowledges and retransmits. But to the server code, you won't get any user commands until the game state has been received. So there's none of there were weird cases where you can be getting user commands in Quake 2 while the server's only partially connected and only has a couple of the config strings. And there were race conditions, like if you modified a config string while the client hadn't gotten all of them, you weren't guaranteed whether they were going to get through or not. And there's some significant issues, and there were some robustness issues with that. But with this new setup, it actually just works great. So you can have config strings of arbitrary length. They can be generated together as long as the entire connection stream is less than 32K in length. It'll just make sure it gets over to the client. It's actually a faster connection process than you had in Quake 2, because there's less back and forth. And once you've got all of that, which has all the information necessary to deal with the snapshot information, which is basically the states of the entities as it sends it out. Some of the other things that were kind of non-obvious that I learned about the networking over the experience of Quake World, Quake 2. Like when I did Quake World, the instant response packets seemed like the obvious least latency response, where you send a user command and the server immediately it sucks in the command, generates a packet, spits it back out at you, which is the raw minimum latency to go ahead and get response back. But there's a couple aspects to that I had converted Quake 3 over to that from Quake 2, because the Quake 2 10Hz server was less optimal for a lot of reasons. So the plan was to go back to the Quake World instant response setup. But after I went back and did that, I actually found a few things with that aren't as optimal as it looks like. One of the significant things is if you've got a certain percentage of chance of dropping a packet in any given way along a route, so you've got a 1% chance of a packet not making it either to the server or to you. With instant response client-driven packets, it actually means you've got double the chance of not getting a packet as you would otherwise, because there's the chance that the packet that the server sends doesn't make it to you, and there's also the chance that the packet you send to the server doesn't make it there. And since it's client response driven, it never sends the packet back out. So on links that are dropping a lot of packets, that's actually a pretty significant thing, because a dropped packet is actually a change in the flow of messages has a larger effect on gameplay than a fixed amount of latency. So that was kind of eye-opening to kind of realize that you're actually dropping twice as many packets as you need to. And the other aspect to instant response packets is that it actually can waste a really significant amount of bandwidth over what you would have otherwise. Because if you're on a local network, instant response is actually perfect. You send off a packet before you render your frame, the server will have returned one to you by the time you render your frame before you process the next the next local prediction or whatever, and that's really perfect. You will almost always have absolutely the latest updated information immediately. But as soon as you're on a link where the average latency is longer than the average frame time, you run into the interesting situation that you have packets arriving, roughly assuming no drops, at the same rate that you're rendering frames, but because frame rates aren't exactly constant and the delivery times of the internet aren't exactly constant, then you've got this beat frequency interference pattern of, if they all get through and there's only small standard deviations, you'll get either 0, 1, or 2 packets actually received per frame, because the frame time, if everything was exactly consistent, you would get exactly 1 update per frame, because you're sending 1 out and you're getting 1 back. But because frame times change and delivery times change, you vary between 0 and 2, assuming no really drastic leaps where you can go ahead and vary between very large numbers. But on a really high quality connection, then varying between 0 and 2 means some frames you get no updates, some frames you get 1 just like you intend, but on the frames where you get 2, it means you read in a message, and then you immediately read in another message, just discarding the contents of what you had before. So you can actually waste, up to like half of your bandwidth there in some conditions, generally at least a third of just bandwidth that's completely wasted. You get packets back and immediately discard their contents. Now, on a bandwidth limited system where you're using a rate command to choke things down, there's the other aspect of the way rate has been handled in Quake World and Quake 2. It was a necessary thing, and it certainly helped the situation there, but it was also not optimal in the network management that it would use, because in Quake 2 especially, with only 10 hertz base server time, you have the situation of, if you overcommit your bandwidth just fractionally, instead of getting 10 updates a second, you get 5. And that's just, that's a catastrophic drop there. Now in Quake World, it's less of a problem because the average frame rate's pretty high. You wind up, but it's still, you wind up getting half the updates instead of a slightly smaller amount that you would actually want. So what we do in Quake Arena now is the server is not instant response based. You set a number of frames, a number of updates that you'd like to try and get. You can set 10 to be similar to Quake 2 or 20 to be similar to Quake 1, or you can set it very high. You can go ahead and set it at 30 or 40, but the rate estimator then becomes a more important thing, because instead of only being able to send out at fixed times, like the way Quake and Quake 2 worked was the server sent everybody's packets out at effectively the same time at these 10 or 20 hertz intervals. But now the server can go ahead and kind of schedule packet deliveries at an arbitrary time. So if your bandwidth overcommitted, instead of just dropping this opportunity and waiting till the next one, it stretches the time that you're going to have before the next one. So it will actually be very close to like 100% bandwidth utilization. So instead of having dropped frames, you have stretched frames. So if you set up and want 20 hertz base update, and you go over the bandwidth that you've allocated for yourself, you can drop to 19 or 18 or whatever. And this works extremely well. This allows a single server to serve people with whatever level of bandwidth they want, and they get as many updates as they possibly can. It does mean that the rate estimation is much more crucial to be right. If you have a rate estimator that is marginally higher, you can go ahead and have your lag pile up. I haven't done it yet, but I'm probably going to wind up having some code in there that looks for those situations of lag increasing linearly with the number of time and have it go ahead and kick your rate down. It's one of those things that seems like it should be able to be done automatically, but it's because of the level of variability that you've got on the internet, it's not as easy as it sounds, but I do intend to do some work to that. But it just means that rates will generally be more conservative. Also, rates now are also handling, we account for UDP header length and some other things on there. So it's there's a little bit less variability there, but the estimate is more important. But overall, those are some of the keys to the improved networking that we've got going now, where it's fundamentally better at the actual delivery rate, and then we're doing a lot better things with the data that we get. We make sure we get as much data as we can in as timely a fashion as we can, and then we use the combination of interpolation and extrapolation to go ahead and smooth out and present the data, in a better way than we have been able to before. So there's both real improvements and perceived improvements, and the networking stuff's pretty much nailed down. I'm basically done with all that. We're ready to start some of our testing fairly soon on just over the general internet, and most things are done there. So that part of it's pretty much wrapped up. On other sides, the big thing that I'm working on right now is finishing up the interpreter stuff, going ahead and getting all that stuff ready. That's a crucial must-have thing. and I jump over to graphic stuff every now and then to to help finish things up with Brian. Like I just just last night, in fact, figured out one of the remaining things about how to deal with a bunch of translucent surfaces in fogged areas, which is kind of significant issue, as we have a whole lot more things that have different translucent surfaces, and like almost all the bonus items have some degree of blending that doesn't work with native fogging. So we've got a few minor things left to tweak out in the graphics stuff, but the graphics pipeline also has worked out really well. The interface that we've got for separating geometry completely from the surface attributes that go on, and the parameterization that we've got in surface files, as we're beginning to see the real payoffs of that now, as we get tons of special effects in really quickly. And it turns out that a lot of it's user level configurable, where it's text files that control the combination of maps and blending and texture and modulation assignments, and that's working out quite nicely. We did just get like some of the better sky effects working, where you can have arbitrary layers of parallaxing clouds. You can change the curvature of the world, so it's not a flat plane of clouds rolling overhead. You can change the ratio of cloud height to world diameter, and it actually properly calculates the bending behind of clouds as it approaches the horizon. So it's not like it's not like Quake 1, where towards the horizon it got it approached asymptotes, and it's not a flat plane overhead. It really is it's a good modeling of a layer above you on a curved sphere. Now, to be reasonable, you don't actually have values that approach real world, where you've got clouds at several thousand feet and an 8,000 mile diameter world. It would cause too much compression near horizons, but you can still go ahead and get nice value where you can see a sense of turbulence and curvature down there. And we have the option of, if you make an environment box, you can stencil out mountains and stuff with alpha and have clouds actually go behind curve away behind mountains, which is a nice thing. So you'll have the option of turning off the extra cloud layers for performance if you don't care about seeing that. You can have a fixed solid environment map, basically just like Quake 2. So it's kind of divided into 3 virtual layers, where you've got the upper atmosphere in the environment box, and then you've got cloud layers 0 or more up to we'll probably have an upper limit of probably 3 cloud layers or something, and then the mountains that you can have in front of that. But that's actually part of the same environment map image, where you just have an alpha channel stenciling out the mountain areas that you want over the clouds, and let the clouds go behind them. Other graphics things, we're still working on some different aspects of lighting. I haven't absolutely nailed down what I want to do with all that. Right now we're still working with a fairly simple lighting model, although we have kind of neat effect on the way the sky environment map is lighting things, in that the sky environment map actually samples the colors in that to determine which part of sky lighting is affecting an object. So if you have a red sunset on one side and blue sky in the other, a building will have red light on one side and blue on the other. It's a pretty subtle effect, and it's something that on most 16-bit cards is just lost in the mud. But on 32-bit color cards, it's an aspect of better lighting that by itself no big deal. But if we wind up unifying all the lighting the way I'd like to, it won't be like a glitzy, just flashy, high-tech type thing, but it's a subtle thing that adds to a good sense of presence in the world when the lighting actually looks reasonable across all that. And I mean, that's still one of the things that we run across constantly with artists and level designers, of trying to get realistic sources of light everywhere. Get enough light, light fixture textures, and get them placed in the world, rather than just dropping invisible light emitting point sources all over the place. So that's something that we're still working towards. It hasn't been exactly nailed down how sophisticated the stuff we're doing. And the nice thing is, the simple stuff that we're doing now is like really fast. We move to a radiosity-based solution again, or a photon tracing or something, then it's back down to taking a significant amount of time on for the processing. So there's always trade-offs there. Some of the things in the combinations of like the way the lighting's done and the shading's done, is you can do colossally sized environments with no real speed hit. You can go ahead and have a box room now that stretches from the entire 8K by 8K region, and it can still be 2 polygons if you want it to be. You've got complete control over the level of detail there. So I mean, there's no preclusion to doing big complex outdoor areas. but you have to, you do still have to watch the total amount of detail that you put in. Because if you make big outdoor areas that are that are really simple, it'll work fine. There's still network issues about you don't want to see 30 people out in some giant area, and you don't necessarily want players walking, spending 5 minutes with the forward button held down to walk across things. But the sheer size of the world is another thing that I haven't perfectly decided if I want to do this, but I will likely wind up with one of two options. Right now, the network layer is the limit on the total size of the map to afford, I set aside 12 bits or 13 bits for communication and position. The rendering code and the server code it doesn't care. You can have larger things, but you actually wrap around in the world when you cross those boundaries, because I've been coding those things as shorts. I have two options to go from there for people who want to make much larger worlds. And one is to have an option to determine the number of fractional bits that you've got. So you go ahead and keep it as 16-bit shorts, but if you want to have a world that's 4 times as big, you lose 1 bit of your fractional precision. Now you can kind of see that when, if you time scale way down and try and move really slow, you can see where it winds up quantizing the movements to a degree where it's not perfectly smooth, it's latching at little areas, and there's some minor issues with exactly which velocity states you can attain. But that's certainly a doable thing. It's almost no work or chance of having problems, and it doesn't affect the network bandwidth. The other option is to just go ahead and have a flag to allow coordinates to be sent as full floats, which then opens up the entire world of until you run into floating point range limitations. But bigger than anyone's likely to want to make a Quake world with that. But that does have an impact on actual bandwidth. A significant chunk of the actual bandwidth that's sent over is for raw coordinate information. So doubling that would probably preclude general modem play. But for people that want to do something that's, for people that have more bandwidth and they want to do some great giant world, that's an option. It's likely that the coordinate precision flag option is going to be more practical, but it does seem that, to try and make the engine as general as possible, but the attraction of allowing floats if you want to use them has some appeal, but I'm not exactly sure what's going to wind up with that. Other aspects of the code, you've got, basically the code's come along really pretty nicely. I'm very happy with the architectural decisions that have been made with how things are separated, the changes in the rendering architecture, the changes in the network architecture. Overall, it's going pretty well. And the gameplay is, we're at the point now where enough stuff works that we are actively tweaking and tuning the gameplay. It does have some of the fundamental decisions that we've made are to make it more game-oriented, more like an arcade game than an adventure game, in that we don't mind having some things that they're almost out of context in a deep booty shooter. I mean, we've got some extra feedback things with beeps and messages and things that do add to the gameplay, but we probably wouldn't have put in a standard game where we're trying hard to have a certain type of mood in the atmosphere. But a lot of the push has been to make the gameplay feels a lot more violent than certainly Quake 2, and in a lot of ways it has more damage feedback than Quake World had also. Take that up with the level designers. I'm with you. I mean, lava is a useful area light source, but you never feel it's not quite the same falling to lava as falling to a worthy adversary. So, I'm not a lava fan. So yeah.
I just had a few questions. First of all, is there any concern with clients being able to do this, like custom layout space, with direct screen control, with them giving players information that the client has, players?
Well, that's the whole cheating, the cheating aspect there, where our scanner system is completely done on the client side. The server just sends over, you have the scanner power up, and then it's able to go ahead and show you where all the other players are. So yeah, that's certainly an issue for cheating, which is why we need the ability to have valid checksum on the client stuff. So the server needs to know, is the client running the authorized version of the code? And I plan on wrapping that up pretty much with all the other data stuff, where you have to have all the right data unless cheating is enabled on the server. Now, if the server enables cheating, then you can there's valid reasons for that to do development stuff. So we still want to have the ability of linking to a binary DLL so we can use MSDev to debug inside there. So we'll have the option of doing that, but that's strictly only if server cheats are enabled. Will you allow the client to go ahead and link to an arbitrary set of data, which is useful for other debugging purposes. Yeah, we're going to take other questions. Yeah.
See, the advent of 98 most likely be the last release before they go to MT and client. The popularity of distributed computing groups. Do you see things happening along the lines of splitting the role of the server code, maybe having like you do with DCS, security server, CDS server?
Okay, some of the issues with distributing the computing load, I have done a fair amount of work on this in different ways. Where one of the goals has been, probably the more pressing goal, is SMP acceleration on the client side. I would like people to be able to get a speed boost from dual processors. There's some updates since like the big plan file I did about the producer-consumer stuff, in that in some testing, I have found some sweeter spots for the communication there on some curious asides on Pentium 2 level architecture. If you flush information from another processor's L1 cache, it's actually slower than if it comes from their L2 cache. And they've also made significant changes in Pentium Pro to Klamath to Deschutes to Katmai. So there's a lot of changes in there, where the early Pentium Pro is kind of the system that I was looking at. We have all these dual Pentium Pro 200s, and my goal was to try and make one of these work like a Pentium 2 300. And unfortunately, the Pentium Pro producer-consumer is really pretty poor, and I don't think there's not an opportunity for fine-grained parallelism like that, like at the OpenGL level. I mean, it was a worthwhile thing to try, because then anybody running an OpenGL app could have just connected to this wrapper, and Half-Life and Sin and all that stuff could have just worked with that. But it doesn't look like that's going to be feasible on most processors. On the latest stuff, on Deschutes, Pentium 2 350 and greater systems, the communication bandwidth actually is a lot better. So I'm probably going to go back and take another shot at the fine-grained parallelism stuff. And there's some other potential options there. But the more likely benefit that will be, that will help everything, is splitting it off at a much coarser level, like at the entrance to the renderer, because there's a few other things that we can do there. In a single player terms, that's not, on a network client term, that's not going to be that much of a help, because even with interpreted client-side stuff and all the network stuff, it's unlikely that's going to be more than like 15% of the, the CPU time. There's a possibility of getting somewhat better total overlap with hardware with minor syncing benefits, but as a network client, it's unlikely to generate more than like a 20% speed boost. Playing single player, where you've got the server load also, you can generate more of a boost, but hooking in there's no opportunity for like even a 50% speed up on there, which is kind of unfortunate. There are places that I can hook in further into the renderer, like where we build, after we've built and sorted our surface list, could be something where we can go ahead and maybe knock another 20% onto there, but that would require a pretty significant amount of work and wouldn't help for this other, the other aspect of hooking it out at the renderer level is we have the option then of supporting multi-pipe rendering for like cave views. If we've got a nice situation where we can go ahead and just fire, if the renderer becomes a write-only API where you never receive anything back, then you can go ahead and be firing off to either multiple processors running or even processors over a network, so you can do side view screens or 4 or 5-sided caves. And that's something that's, it's not important, but I'd like to enable that. And if the one architecture of putting the SMP stuff there, works out, then we can get, so we maybe give a 10 or 15%, minor speed boost to people that are running as clients, but we'll also enable people to run, potentially things like stereo views or cave views faster. It's a worthwhile architectural thing also to convert to a write-only API. Some minor differences that instead of asking for a model and getting back a handle to it, it's more like OpenGL's texture stuff where you say bind this object to this handle that I provide, and that's it's a useful thing for programmers to think about removing all return values from an API. And I remember the first time that I looked at OpenGL, I didn't really understand why you did that with textures instead of just getting a texture handle back. But it's for the same reason that we want to do it here. So you can pipe across like an arbitrarily length network connection with minimal communications back, and it's actually a really good design. On the server side, I spent some time looking at what we could do for, because one of the goals is infinite scalability, to be able to do something with transparent handoffs and all that. And I decided that there's enough other issues that it's not going to be a focus of my time now, because for one thing, we have the limitations on, right now, network communication stuff. That would have to be solved before we scale to something larger. The amount of work in there, I spent some time going through it about what would actually be necessary to bring in S&P work into the server side, and it's actually a pretty non-trivial amount of work, because what you basically need is a lock on each entity that you might be modifying. Now, there's lots of parallelism actually there. Most interactions that happen are between local objects that have nothing to do with the vast majority of them, and it's certainly possible to design a parallel architecture there. But the way all of the server code is architected right now, pretty much you just go ahead and muck with entities if you want. You get an entity back, you hit it, and that's just kind of the standard everywhere. And to go in and encapsulate all that stuff in locks would be a pretty error-prone, significant process. And there's certainly interesting things that I was thinking about in terms of multiple servers and proxy handoffs, where you could wind up connecting to a proxy which could seamlessly take you from one server to another, and things like entity renumbering to, you could have a fixed, you could even get by with a smaller entity number, which could actually improve bandwidth. You could have, say, 256 entities, which a proxy wound up renumbering from an arbitrarily large thing, which would provide some small bandwidth benefits right now, as well as some scalability issues. But it's not something that that I can hack together over a weekend as a proof of concept, and I think I've got enough other stuff on the plate right now. I think that right now it's at a reasonable balance point where servers that are going to be available, if you take an alpha server or a Catmy 500 or something, and take a map that fills out to our current limits, we've got a pretty good balance now. If you build an 8K by 8K map and put 80 or 90 people on it or something, there will be CPUs available that can actually handle that load fairly. But it seems to be a good balance point at the edges of what our current data limitations are, and the edges of what we can get on single processor CPUs. There's some minor benefits that I can do on decoupling the backends, on building the delta messages and stuff like that could account for maybe a 20% server boost, and potentially be able to feed the operating system packets in a steadier path rather than in the bursts. But it's not the significant thing. I mean, ideally, what I'd love to do as a server thing, and it would be an amusing project, but it would take some time, is something that was scalable enough that, if we wanted to, you could take a 16 processor SGI and run a server that's going to support 1,000 players, or do something like that.
We can play around with those ideas. I work with IBM, and I work with a multi-processor risk environment. And DC is very popular in that respect, where you can take multiple, what used to be thought of as one large server, break up to multiple servers, each have a role, although they're all playing on a large part. So I was wondering if you ever thought of that.
It's an interesting problem that I would like to look into, because you want to connect and have the single system image. I mean, there's stuff that you can do right now with, you can do non-transparent handoff, walk through here and you're connected to another server. That works, it works cleanly, but you still wind up getting a loading screen in between, and it's not completely seamless. And I think the right way of doing that is to have multiple independent servers with a proxy in between you that does communications, coordination, and renumbering. But it's a pretty significant chunk of work. But speaking of some other network things, the interface that we've got to network games, we've still got the standard stuff inside the menus for addressless local servers and all that. But the plan for the wire stuff is I've got a plugin for Netscape or Internet Explorer, which is basically a minimalist version of GameSpy. In that, GameSpy is not simple enough for your average user. It's a power user's tool, and it's got all sorts of features that most people are never going to look at. And what I've got is something that takes in a list, just in a browser web page. You can generate it from HTML, so you can have, I expect to see a lot of these lists rather than a monolithic master server, but it just takes in a small list, produces the one top view that has the quick info stuff. You will have a sort by ping option, then click on the server and you see the rules and the players and to double click to launch the game. You know, pretty straightforward and simple. It doesn't have a lot. I mean, there are no menus, no controls. It's just, you know, like 3 list views on there with you know, with like 2 buttons. And I think that's going to be a nice interface for a lot of things where I would like to see more kind of micro masters like that, where you have like anybody that's doing a major modification would go ahead and advertise a small master, so that if you want to find all the mods running this, you just go to that page, and at the bottom of the web page is the little sorted list of everything. And that's what I'd like to see start happening in more interacting between web pages and the gameplay, so that you can have the server list there, or have you know, some of the options of, I'd like to have some way to go backwards also, where like in a game you can have like an option of launching your web browser to go to the server's link to see about different things. And I think that's going to be nice, because we want to make it really, really easy for people to go ahead and, the goal is to be able to have like be 3 clicks away launching the game from playing on the internet. And we know that we're not going to provide every feature everyone wants in there, but I mean, actually, we're going to give away the source code to that. So if somebody wants to, you know, modify that to make it more sophisticated, and it will work with GameSpy and all the stuff that has, if you want to do user searches and logging of all this other stuff, that stuff will still be there. But we want to provide something that, you know, that will be much simpler, because we have kind of 2 sets of goals where we want to expand things with this game. We want to make Quake Arena better for everybody that loves action, you know, action multiplayer games in the first-person shooter genre. You know, the intent is to have nobody that still likes Quake or Quake World or Quake 2 better than the new game. And I think that we're generally going to be able to, you know, to achieve that goal, where there are valid criticisms of the different games that I think that there's a synthesis that we can reach that does make everyone clearly aware this is a better game, you know, in every respect. And even if like you don't like the way a certain weapon happens in here, I think most people that, you know, that have at least an open mind will be able to say that, you know, on the whole it's a better game, and we want to move over and unify the user base. But the other thing that we want to do is make it more approachable for, you know, just kind of your average person. You want to be able to, like, one of our goals is that, you know, we want the game to be something that we can give to like our secretary and expect her to be able to play, you know, or you give to your father and ask him to like jump in and play. Part of that's going to be like making levels that are not as sophisticated, levels that, you know, we'll have an entire set of levels that are pretty much flat, where looking up and down is not required, and someone could even, you know, play the game with the keyboard if they wanted to. Because I mean, it's easy for people that have been playing this stuff for, you know, for years and years to, you know, just assume that the mouse is intuitive to everyone. But I mean, if you think back to like the very first time you played with the mouse, you were like looking at the ceiling, falling off things, running backwards, and you know, it's not as intuitive as everyone necessarily thinks it is right now. It is the most efficient interface, but it's not necessarily the easiest. So we want to make it easier for people to play under some conditions, you know, other than the hardcore community. And part of that's also going to be as far as configuration and connecting to the internet and doing a bunch of things like that. Like one other aspect of having a web-based interface to that is that if people are already connected to the web, it means their UDP is working, they're dialed up to their ISP, and all that stuff's just there. And if they're connected to a web page, the game should launch and should connect and work right there. And there's a few other aspects that we're doing in some of the things to, you know, to try and make the game more sensible and easier for, you know, for newcomers, because we want to grow the community to people that, I mean, there's at least 50,000 ultra hardcore and several 100,000 more, you know, common players on the internet. But we want to make a game that can have 1 million customers to it, just, you know, like the previous single player games. But that does involve extending a little bit beyond the current like hardcore group. And generally, it should make the game better, you know, in every way, because we don't think we're compromising anything in any ways. But it does mean there's a little bit more reliance on some simple elements. You know, certain things that, where certain rules and everything are not necessarily, we wouldn't do something that's like hideously complex. I mean, we'll leave that to, you know, a lot of modifications. There are people that want to know 20 different keyboard commands for different things, and you know, it's a valid style of game. It's just not a widely targeted audience, and there will be people that have a good time doing games like that. But like for instance, just yesterday we wound up taking out one of the tweaky rules on, you know, we had put in stuff for like headshot, leg shot, variable damage stuff, and we just reached the conclusion that's just a crappy rule. It just adds more randomness to the entire game. it's one thing when you've got like a precise single player game and slow moving things where you can like exactly target in, but if you're running around shooting at things, all it does is add a feeling of randomness to the game where, oh, I died from 3 plasma shots that time instead of 6 because, I happened to be like getting hit in the head while I was playing the light model or something, and there was a feeling of, of inconsistency there. So I finally took that out, and there's, other sets of features that, that may be requested that that we do just take the stand of trying to be as simple as possible and have a simple, clean set of rules. But we're so incredibly extensible that I'm sure there will be quickly modifications with advanced Wake Arena and stuff like that everybody wants to, and that'll sort itself out in the community. But we want to make it easy enough for new people to just go ahead and jump in and play with a consistent, simple set of rules that we can get a lot of new people in playing the game. Questions? Yeah.
When you're experimenting with running the client-side code through the FA JVM, how much performance were you getting compared to using your standard C interpreter?
Okay, I didn't actually, that would have involved porting those 10,000 lines of code to Java, which I did not do. But I had set up some interpreted Java should be slower than QC because it's it's stack-based and it's byte-coded instead of having general fields. But it's in the same ballpark. I mean, maybe it's 20 or 30% slower, but once you're down that factor of 10, that's all kind of noise. It would have been about like QC. Yeah.
On the network side of things, can you explain what you meant by the RAID system or how you have bandwidth saturation?
Okay, what happens, like when Quake first came out, the really bad sets of lag that people would see was when bandwidth was overestimated, and well, bandwidth wasn't estimated, it was when bandwidth was overcommitted. What happens is, on the modem or virtual modem at your ISP, if you wind up sending more data that can actually be transmitted over the phone line, it backs up in a buffer, and that buffer size depends on the modem or ISP or whatever, but in many cases, it's several K. Now, if your modem's only syncing about 3K a second, and you buffer up 5K, 5K of data there, like, if you're sending packets 20 times a second, and you go ahead and the packets are, become 200 bytes, so you've got 4K a second actually going over. So over that time, as it backs up, you wind up at some point where it tosses a packet in, but it's got 6K of data there, so it's going to be 2 seconds before that packet even gets to the phone line. So the way that theoretically you can detect this is if you've got a stable enough flow of packets and you look at the delivery times, you can tell the latency of a single packet because it tells you when the last packet it got from you is. So you can get kind of a timestamp there. It's a little bit more problematic because of the fact that since the packets aren't instant response, it tells you the last time it got one from you, but it's still sending it out sometime later. But theoretically then, if you can know the latency of a given packet, and you notice the latency steadily increasing, it's likely that that's a result of bandwidth overcommit and buffers are piling up. But it's far from foolproof because it's hard to get an accurate ping value on that because they aren't instant response. And then there's also other things that can cause variability in latency. I mean, it's unlikely that random conditions in the net cause a slow, steady rise in latency, but there's lots of things that can cause them to go up or down for a while, which is why I'm not confident that it will exactly work out. But, I mean, if your net connection's going to hell, cutting the rate probably can't hurt. So, I'll probably be tracking some of that. And if, if ping times cross over some high threshold, just start, chopping down the rates. And hopefully after a couple seconds, maybe it comes to a reasonable point. But a worry is that if I have something automatic like that, then there's the possibility that transient bad net connection could crank your rate down to something lower than is optimal for normal conditions. So the safe fallback is to kind of just say, if your connection's screwing up, lower this slider. But, again, it becomes kind of a magic voodoo thing. If my connection's screwing up, I put it down to here, play for a little while, moved it back up, and I'm not sure, whether that's good or bad.
Do you have the client signaling the server as far as the status of the connections and the server doesn't?
Well, the server can also generate, each packet that goes back and forth has a sequence number from the other one. So both sides can kind of tell roughly what the connection latency is by looking at their most recent packet, seeing which sequence it had last acknowledged. But neither of them is precise, and both of them are a conservative estimate, where they're both higher than like if you just do an instant response ping at the command line. And their numbers are also slightly different because of the way the communication's handled. So that they don't exactly match, but they both have rough estimates. I mean, they can tell the difference between a T1 and a modem. Yeah.
With the new networking model, can we hope to see maybe a depth to ping of depth?
Any what? Say again?
With the new networking model, can we see will we see an end to the ping of depth?
Okay, some of the things that could be done, there were some error conditions that could be logged on the current Quake executables where you could trigger a network error which can cause the client to dump out. No network errors are fatal in the current code base. I mean, it is possible for somebody to cause some warnings to spew out, but they can't actually kill your connection. Yeah.
Okay. In the first version of the Quake world, they keep the player stats permanently on the master server, so you can see who's good and whatever.
Yeah.
Is that gonna be put back in Quake Arena? So like the llamas that want to play like your secretary or something could go through the web browser, and they could like choose a server that doesn't have a bunch of badasses on it, so they don't get slaughtered.
Okay, I think the way to do that is to have sets of. We want to basically split the masters into two sets: casual players and hardcore players. And as far as ranking and everything goes, I mean, I kind of enjoyed the Quake World ranking stuff, but there were issues with cheating, and there were valid criticisms that people leveled at it, is that it changed the character of the game when people knew they were being watched and logged. So I don't think that we certainly won't institute any kind of a global ranking, but the idea, I think the right idea is to go ahead and have ranking servers that servers can choose to connect to a ranking server and say we're ranked on here. So it's not necessarily like a central global thing, but like all of the, I would expect that to kind of organize itself spontaneously. We'll have hooks in the proper places so that you can communicate that information, but the global community ranking probably isn't going to happen. It's probably not even a good idea. I mean, it's something more that if the group of serious players that are interested in being ranked, and there's a lot of them, tens of thousands probably, that would actually want to play on ranked servers, but I think that it's good for them to go ahead and segregate themselves from the community that just wants to to jump on and have fun and set up their own. Just say this is a ranked server, this is serious here. Maybe even you need to go ahead and apply for a separate username or password to get onto ranked servers. Like that, but that's a more open-ended issue that we're probably going to leave a lot of that to the community. Zoid has mentioned that he's considering doing a more tournament-based server as the first major add-on test, but I haven't kept up with exactly what he's working on that. Yeah.
Yeah. In terms of your, are you going to have hardware accelerated sound, like 3D or?
Okay, 3D accelerated sound is something there's a good chance it's going to make it in since we are finishing up, we're tying up a lot of the other stuff, so there's a pretty good chance that 3D sound is going to get in. Hardware accelerated normal mixing is irrelevant. It doesn't affect enough of the CPU for it. But the 3D sound there's potentially neat things from that. It's more useful as a mood amplifier for the single player game, but from a tactical standpoint, if you're playing with headphones, the extra positional information can actually be useful, and that would be the thrust that would make me want to do that. Yeah.
Yeah. I don't know if you mentioned this earlier, but in terms of your Bezier rendering code, are you using like a uniform for differences technique, or are you using like an adaptive thing? Okay.
The way the curves are rendered, I've gone through three separate sets of rendering on here. The first one that I did involved integral increments of subdivision, which worked out pretty nicely, and I was using direct evaluation, not forward differencing, because it turns out that with modern processors where multiplies can be pipelined at the full rate, there's not that much difference to the extra setup of forward differencing, and just directly evaluating, especially since we're only quadric, we're not doing cubic Beziers, it's just not that much work to do direct evaluation. And that worked out pretty nicely because the level of detail changes there were pretty seamless, where when you change from 3 to 4 to 5, you just don't notice that until you put a specular highlight on it, because when you integrally change that, all the points move. So any highlight that you have is guaranteed to change in shape, and that looked really bad. So I mean, the next thing that I set up was going with power of 2 subdivisions, which you can then really nicely evaluate with just adds and shifts on Bezier curves. That's really nice, but you have less control over the level of detail. They only come in multiples of 2. The place we're at right now is actually pre-tessellating all of the curves, where it's not that much memory to tessellate curves, to a pretty fine degree, and level of detail can come from just removing columns or rows. It's kind of like a one-dimensional progressive mesh in 2 axes, and it's fast and efficient. I mean, it's dead simple, but it actually solves the problem really nicely.
How do you deal with
You poke patches into each other right now. You do not have exact meaning of patches, because one of the issues is, one of the nice benefits, the really strong positive benefits of the pre-tessellation of the patches is when the polygon count dropped to like a third or less of what it was with uniform subdivision. I mean, even though I was doing uniform subdivision, estimating the size of the patch to determine the subdivision, there's still all these cases of where you've got like sharp bends that have degenerate numbers of multiple vertices on top of each other and all that. When I do the pre-tessellation, I have the option of doing a good set of optimization where it actually goes in and builds a mesh by uniform subdivision, and then goes ahead and checks flatness on all of it. It's able to throw out just a ton of triangles on there when it converts a patch from. It's like you can take something with 16 control points, around one axis and 32 on another. So you've got this gigantic number of patches building like a squashed square cylinder arch, and it turns out like 80% sometimes of the triangle vertices are actually nearly coplanar or exactly coplanar. In many cases, it can just be discarded. So we do reduce the mesh count hugely with this pre-processing step, but it does mean that you cannot guarantee that even if you match control points on 2 adjacent meshes, that their curvature over the entire thing may be optimized differently, because the optimization right now does restrict itself to strictly grid, still grid-based. It's not an arbitrary progressive mesh where you can match different number of vertices on one side versus another. So yeah, it's an issue you have to be aware of in the construction. So it does mean there are certain types of things that you can't construct exactly.
Have you had any luck with any sort of progression, non-uniform tessellation along the various
The first, when I was doing the arbitrary tessellation to an arbitrary number, I did the stitching necessary so that you could have a ruled surface, which is a degenerate Bezier in 1 dimension, where you can have different number of points on the top and the bottom, and it works out the stitching order to go ahead and meet those together without T-junctions. So at one point, the code stitched everything together right, because when if you matched up a given control edge exactly with the control points on another, then it would stitch together properly. But it was a fair amount of work, and it's possible to do, but it also gets a lot more when you have compound curves on things. The stitching process then becomes a reasonable chunk of work to go ahead and iterate through all these different ones to handle. To stitch a patch given an arbitrary number of subdivisions on each of the 4 sides is a not entirely trivial problem. It involves a lot of looping and testing, and I did just kind of punt for the simpler solution. If I got a lot of the benefits, getting rid of like 3/4 of the triangles in a common scene, that's a hard thing to, that's a big benefit. And yeah, I did lose some of the things, a whole bunch of micro brushes. I basically created linear geometry that approximated the curves. And that was all fine for little test levels, but as soon as people start making caves out of it, it got unwieldy. And actually, at the moment right now, there's just this big hole where it says intersect bounding box with BSP. I convert the patches now into BSP trees for a face, which is actually, it's not a volumetric BSP tree, it's actually a surface-based BSP tree, which works out pretty well because you don't need a lot of tessellation for the patches, because the size of the players and the movement there, you don't need nearly as much as you need for rendering, but you do need a consistent amount that can't level of detail change, because everyone is local in their own coordinate system. But the honest truth is, right now you're walking through curves. Since I took that stuff out, since we read the BSP format last week, we don't even have the option of compiling with the the old code that made the micro brushes. But it's a proven concept there that converting to linear geometry does work. I just have to convert to a more efficient linear geometry, which is surface-based instead of approximating a surface with multiple volumes, which is generating, in many cases, like 20,000 little brushes to approximate a curve. So, I mean, 20,000 faces is no problem, like making a BSP tree with 20,000 little faces, but if each brush has to be an enclosed volume, which requires, at a minimum 4 separate faces plus bevel edges, that just multiplied, way out of control. So, I mean, that's still, one of the chunks that there's one function I need to implement to actually do that intersection there, and I've been kind of dodging that for a while because I've had other stuff I need to do, because the reason why I went to the micro brushes, one of the early things that I had done was analytical intersection with the patches, where I would do basically just iterative methods to find the point of intersection on the patch. And that had some problems of, like, if you have a smooth curve up to some piece of linear geometry, the physics collision intersection is still a really tweaky part of code in general, with lots of little epsilon issues and how creases and slowly sliding into things are handled. And that's exactly what I ran into when I was doing analytical intersection, where you would have problems where if you just had a curve in the middle of a room, you'd go up and you'd interact with it fine. But when you had it interacting with other curves or with other linear geometry in the world, it was causing problems. So when I tessellated to basically linear brushes, then everything just worked right. In fact, there was an option in the BSP tool to go ahead and have it output those brushes so you could load it back up in the map editor and see exactly what brushes the curves were turning into. So it's clear that works. Now I just have to convert that to a more space-efficient manner, which does involve a completely new primitive to intersect with, but it's still linear geometry, so I know it'll give me headaches, but it's solvable. Yeah.
Are you going to have level of detail?
Sorry, I can't hear.
Are you going to have level of detail sliders for, like...
Okay, the way level of detail works is I've done work with progressive meshes before, which have the nice ability of pulling in an arbitrary number of vertices. But the drawbacks of why we're not using progressive meshes, for one reason, is it's a non-optimal mesh for a given number of vertices. And perhaps more significantly, you don't get triangle strip information. You have to break all of them up basically into discrete triangles, or you have a lot of problems with that. So what we're doing is basically, it's kind of a low-tech punt, but we have 3 stages of high, medium, low detail models for the levels for the models, and that works out generally pretty good. Like our character models, our base level is like 800 triangles. Next level of detail is 400, which is like a Quake 2 guy. Next level is 200, like a Quake 1 guy, without the weapons. So you do have, you've got a transition point that you can specify per level of detail to determine, based on projected area, when it actually changes over. But I do think that basically dropping by powers of 2 is about the right way to do models, and I think 3 models there is pretty much, I think, the sweet spot for changing level of detail there. It seems to work out generally pretty well. Paul's happy making separate meshes because he's generally happier to make a mesh himself because it's automatically animated. There's no like reanimating work there. It's just creating the mesh rather than having some decimation tool go ahead and do it automatically. There's certainly an appeal to just having tossing models in and having magic code take care of everything, but there are drawbacks to it, and in a lot of cases, we're going with a simple solution here. Yeah.
For like graphics, with OpenGL, the environment looked really good, but software ray trace pseudo ray trace look was even better in my opinion. Are you going to have something like a level of detail for that, or
software ray tracing?
Well, it's kind of a pseudo ray trace look. Like shadows are a lot more defined. Are you going to have that in hardware?
Okay, one of the significant issues with ray tracing is that it's very sensitive to geometry. Any immediate mode, like the Z-buffer type approach, has the really strong benefit of it's linear with the amount of geometry that you throw at it. Or anything where you're actually doing intersection tests gets hideously expensive at the triangle rates that like our typical scenes, the level designers are instructed to stay under 10,000 triangles rendered in a scene and under 6x overdraw. Now, in a situation where there's a lot of nice intersection calculation things you do in a very simple world, like if our world geometry was the level of Quake 1, we would do exact linear intersections to generate light sources, exact shadows, or all models and everything. And that's feasible with our current processing power with that level of geometric complexity. But with like if you want to intersect anything analytically with an 800 triangle runtime deformed mesh, that's a non-trivial amount of work. And for instance, the only way that I think valid shadows are going to be done is with image level things, either shadow buffers or shadow volumes, which wind up being a linear amount of difference per triangle of the shadowing object rather than something that's relative to like the square of the destination triangles and the shadowing objects. Those numbers get really bad really quick. Yeah.
And having any problems with precision of a buffer?
Yes, there are issues with 16-bit Z buffers when you intersect anything. If you run a patch, like you have some goopy thing along the floor going up into a wall, it doesn't take much range at all to have Z buffer precision problems. You get a zippering or stitching effect on there, and there's a couple aspects to this. One is we added separate field of view, not field of view, but depth range CVARs that you can set, where the current skybox was at like 2,300 units, which in some levels, like in Strike, in Quake 2, you could actually see the rear clipping area where the sky was. And if we extended it more, you would have gotten more range problems. I mean, range problems weren't much of an issue in Quake 2 because we did an exact skinning of the world. It was only a case where you had a model behind a relatively thin wall at a great distance that you would run into it. But because now we allow geometry to interpenetrate, it becomes more of an issue. Some of it's taken care of by the level designers, where they know that if you have a 2-pixel thick block and you put it in front of a wall, then it doesn't clip the wall, and you walk a long ways away from it, that it will just interpenetrate in more patterns. Part of it, we have these new CVARs where you can set rear clipping planes separately. So if you want to do a giant outdoor level, you can set the rear clipping plane out. On a 16-bit Z buffer, you'll have a lot of problems with depth aliasing, but on more modern cards where everyone's going, there's viable reasons why someone might want to see across the entire 8K world. If you build geometry that's simple enough for that. But one option that we have now, which I had just brought up to Brian last week actually, is because of our architecture of generating all the surfaces before we render any of them, we, at a slight cost of doing some more vertex tracking, we could actually keep track of exactly what the most distant thing actually in view is, and then we can adjust our depth range dynamically every frame to get the most number of bits of precision possible. And I don't see any real drawbacks to that. There's the possibility that as you rotate to another view, something might start having Z fighting problems, but I think it's a good solution, and since we're already doing the sorting thing, it's likely that that's going to make it in. But yeah, level designers do now need to be aware of Z interaction issues. And there's another minor thing that cards that don't do simultaneous multi-texturing, you have the issue of if you've got something that pokes slightly under it, where even if it wouldn't give a Z fighting problem, where it's just kind of like one column, if it draws all the textures and then draws light maps after it, you can get this double blended darker line at corners. And that's possible in some cases, where you never see that on a card that does multi-texture because it's all done internally. You don't have the separate passes, but it's an issue.
What about bump maps? Do you have support for that?
Okay, the bump map situation is we had one of the early engines running with bump maps on everything. My opinion on bump maps is that it's like texture mapping, where some people are trying to push bump mappings for spot effects, and I just don't think that's the right direction. It's just like nobody ever made a successful product that mixed texture mapping and Moreau shading. I think bump mapping is like that. When you do bump mapping, you should do bump mapping on everything. And the issue there is there's the speed performance issue depending on how you implement it. There's the significant quality issue of what happens when it bitmaps, and then there's the issue of just artist time and unfamiliarity with developing that. I mean, we had a small level that had a few bump map textures that the artist created in there, and we're using my channel-based bump mapping algorithm. It does map correctly, but it involves like 4 extra passes over the screen. So I mean, it's really performance intensive, but it does give the right effects as it proceeds in view, which anything that's normal encoded base doesn't do, and actually just kind of falls apart into noise. But the feature was definitely killed when we decided to go towards the higher performance, faster action game rather than trying to do the really lush world. It just wouldn't have been a sensible thing. But the other issue was we were worried about the media development time. I mean, each new map that we set up here takes longer for the artists to deal with. And Kevin and Adrian were just, this was their first jump into working in 24-bit color at all, coming from Deluxe Paint. And it's a big enough transition as it is right now without having to work in these completely, in many cases, non-intuitive ways of doing the color in one area and the bumps in the other. I do think bump mapping will be a significant step in the future, but there's still significant unresolved questions about exactly how you represent the light field, because there's well, for a single object that's going to sit on a table, you can represent the light field very nicely with an environment map. And you can do bump mapping becomes perturbations inside the environment map, but that actually doesn't work if you try and do an environment with bump mapping, where you have to handle, this room, say, has this huge number of light sources coming from the ceiling, not to mention secondary reflections, and to have bump mapping deal with that in a general fashion requires specifying ambient lights, and then you want sharp point lights to give different shadows, and it's actually not a completely nailed down problem even in research circles. So the place where I do think bump mapping can be profitably used in games today is in orthographic views. If you've got a game that basically looks down over a fairly fixed view and doesn't have things that recede way off into perspective, I think that's a valid way to do any of the various cheesy types of bump mapping that are available now with like texture offset or texture lookup. They work pretty well in situations like that, but if you're able to recede those views off into perspective